Here I am in Tash in Switzerland, and this is where my adventure starts. We want to witness and analyze how the Gorner Glacier is shrinking. And why would an astronaut be going on an expedition like this? What does an astronaut have to do with a glacier? Well, it just so happened that when I was in orbit on the ISS, I took many pictures. And over the arc of about 6 years, from the first mission to the second, I saw with my own eyes the glacier slowly disappearing. It struck me. And so this group of scientists and climatologists asked me to come here and see it with my own eyes on the ground, what I'd seen from space. Then the helicopter starts flying sideways. Because the twin blades are not in a natural configuration, because they rotate like this, the helicopter wants to fly. Frank, I'm here for the very first time, and it is a very unique environment to be.
Certainly.
And a very unusual one for an astronaut. Tell me a little bit, what am I looking at?
We're here in the beautiful Zermatt region. We are surrounded by the highest mountains we have in Switzerland. So it's actually the peak behind us is the highest mountain in Switzerland, and we have these beautiful glaciers.
Glaciers are living things. They change. They change with time. They change with climate, and they change with meteorological conditions as well. What is the story that the Gorner is going to tell us in the next couple of days?
Here we are in a very special place because all glaciers are composed of compressed snow, so this is not frozen water. And the snow that is the source of this glacier comes from the highest elevations up there at Dufourspitze. And at this elevation it is so cold that there's basically no melt all over the year, which means that the snow by the layers from further years is compacted more and more without melting. We name this somehow a dry recrystallization, which is the same process as in Greenland, for example. Okay. And this does only take place here and has this special, consequence that a part of the ice that we see down there at Gorner Glacier is so-called cold ice. So it is below 0 degrees. It is not as all the other ice at the so-called pressure melting point. That means when you put some energy into the other ice or some pressure, the ice would melt. And this is not the case here for this central part. It appears also very white. Here in this case, The white ice is also a little bit self-protecting because it is so bright. It reflects more of the sunlight, so that in the end the melt should not be so strong as for the darker grayer ice. And here this glacier, or this central part of the glacier with the cold ice, is really unique and the core of many studies.
One of the things that meteorologists and geophysicists study is also the ongoing changes in global climate. Is it something that is affecting this glacier as well?
Yeah, the global increase in temperatures is affecting,
global warming.
Is affecting all glaciers all over the world in exactly the same way. Thanks to the satellite data, a recently published study has shown that this meltdown of the glaciers is really all over the world. So, and it has also accelerated all over the world. And this is a little bit, let's say, the worst side of it, because glaciers adjust to the climate by changing their size.
Felt safer in my life, I'll tell you. It is a truly humbling experience to be up here in the beautiful setting of the Swiss Alps. I've only seen these images from space. I have taken many pictures of these locations and what is happening here, and to actually see with my own eyes and feel under my feet the rocks of the Swiss Alps, it's amazing. It's almost unbelievable. And now I've been up for 12 hours. I have eaten a couple of granola bars during the day. I've hiked for 5 hours, so I'm hungry and I'm ready to go eat something. We looked at a couple of things. First, we found Mulan. It's a shaft where water, melt water, converges from river systems that are formed by the melting of the glacier, and then they go into the ice and melt it, creating this shaft. And the images are amazing. It's beautiful, although it is a sign of something terrible happening. Again, the melting of the glacier. And then once it goes underneath the glacier, it just flows towards the valley.
Qua dietro abbiamo un inghiottitoio che prende il nome, come hai detto tu, mulino, il mulino. Ve ne sono tanti sul ghiacciaio e ti posso dire che il numero sta aumentando e soprattutto la quantità di acqua. Adesso stiamo vedendo una vedière, cioè questo ruscello, prende il nome di vedière, che è molto piccolo, ma in realtà ce ne sono tantissime e sono diffuse in tutto il ghiacciaio. Questo ci dice che la maggior parte dell'acqua di fusione poi finisce nel cuore del ghiacciaio e da qualche parte trova una via per fluire verso valle.
For monitoring glaciers, we use different tools, and that depends very much on the scale that we are monitoring. For example, we do assessment of glacier changes all across the Earth, and they are very much focused or based on remote sensing observations. So satellites that look at Earth either visually, so with pictures, or through radar, or through altimeters, so a range of tools. For the monitoring of Swiss glaciers, we also have in situ observations, so measurements that are done at the very site. What you're holding there, it's what we call an ablation pole, an ablation stick. So it's a device, it's maybe a bit exaggerated, but it's a pole that will stick in the ice with the drill, and we'll use that to tell how much the glacier is melting. And well, if you want, you could do the job yourself, and I will show you. So I'm sure you know how to operate the drill. Just make sure when you start, make a little hole on it, and then try to have it as straight as possible, otherwise it will bend. And while
I'll do my best. I've never drilled a hole in the ice, but
try to exactly hold the hand there. That will give you control. And whilst you're going down, come up a bit. Yeah, exactly, so that you get rid of this pieces of ice that we are drilling through. That's it.
Okay.
And now
put this one down, or you want to hold it?
We can put that away. But yeah, you can get the ablation pole again.
Okay, so the ablation is just a scientific word for melting.
Yeah, correctly. So what we distinguish in the glacier cases is ablation, so the process that remove mass from the glacier, and here the main process is the melt.
Okay.
And accumulation, that would be the process by which we add mass to the melt.
So when it snows and it covers everything with snow,
exactly.
And then eventually that pressure from the snow will create new ice.
That's correct, yeah. This is something that doesn't happen in this very place, because here we are in what we call the ablation zone. So it's the zone on the glacier where we lose more ice to melt during summer that we can add to snowfall during winter. Whilst higher up, so in the regions that we see up there, there we are in the accumulation zone. So there we gain more snow during the year than we can lose during summer through melt.
So this is an important part that really explains the dynamic of a glacier. So let's say that again in common words that even an astronaut can understand. So basically this is like a river. It's flowing down from the place up there in the mountains where During winter, it snows, it accumulates, it creates a lot of ice, and then eventually flows out down here. Here, we don't really get more ice. We just get whatever it's coming down from the mountain. And during the summer, we get this ablation process, which is the melting of the ice, that creates a lot of water, rivers that go down to the valley.
You got it.
Did I say it pretty much okay?
Yeah, exactly.
Excellent.
And this flow is what is happening there is the ice deforming underneath its own weight. So you can imagine like a slab where you would put some honey on it. This will kind of make its way down, and the glaciers, as you said it, do exactly the same. So they make down the valleys by deforming themselves. Why don't we go ahead here? For that you have the 3 poles. That would be easier to do that. We take that this way. Just, and the pole we have put here. So what we have here is the camera that will place to look at this very spot.
Okay.
And during the day, while the melt is happening, this will lower. And so what you will see is basically this ring sliding down the way.
Okay.
And well, in a bright day like this, at this elevation, we may see like 5 to 10 centimeters, so something like of melt. So when we come back in the evening, well, basically we are not walking over the same ice again because it will have melted by then already.
So this all part of the glacier is melting at the same speed, and that's about 10 centimeters a day on a hot day.
On a very hot day, yeah.
On a very hot day. So let's say 5 to 10 centimeters per day on average over the summer. So how much of this will have melted compared to from the beginning of the season to the end? How much ice will we have lost?
At the place where we stand, I would guess 3 meters.
3 meters.
So that's putting myself on top of your shoulders. That's more or less what, if I sit on you. That's the amount of ice we lose every year here.
Every year we lose 3 meters of ice. Now, this is the question that's been burning me. Will we recover any of that in the next year, in the next winter? Will we recover any of that ice?
Well, unfortunately not, because indeed during winter we will have snowfall here. So when we are here in winter, you may have like up to 4 meters of snow. But this will go and melt away again at the next year. So we'll find the ice that will leave during winter. We have a bit of new ice coming in, that's the one flowing down the mountain. But in that time, the stake will have moved. So the ice that flows down is kind of pushing our stake away. And so the answer to your question is basically no, unfortunately, we won't grow the glacier during winter.
There are 3 stark issues that are associated with glacier retreat. So on the one hand, we have a change in the hydrological system. So we get a lot of runoff. There are lakes that build in front of our mountain glaciers. And these can cause hazards. So there can be dams that break and flash flooding that happens. So we have also an increase in hazards in the mountain areas. When there is less ice, the mountain also the forces are differently distributed on the mountain. So we may have more rock falls, and the hazard zones are actually expanding. Then we also have the issue that when we lose ice, it flows into the ocean, and glaciers actually contribute to global mean sea level rise, and they contribute quite a lot. So from a climate perspective, that is a worrying aspect as well.
There is a system of caves. They are contact caves. It means that the glacier is touching the rock, and then the water plus the hot air from the outside mix together to create these incredible structures that are underneath the glacier. Unfortunately, despite their beauty, this also means that the the roof of the glacier is getting thinner because of the hot air, and it is another sign that a few years from now, what I'm looking at today will not exist anymore. Probably next year, the cave that I was in will not be there. The roof of the glacier will be so thin that it will collapse, and then when I was standing under the ice, it will be just bare rock.
Fenomeni come questi stanno accelerando, cioè l'acqua che arriva da di lato sta entrando sotto il ghiacciaio e sta creando dei vuoti, ma siccome ci sono più ingressi c'è una circolazione d'aria e di conseguenza hai acqua più aria, quindi la fusione è aumentata anche con la circolazione d'aria. Ecco perché sta accelerando tutto questo processo.
So we are looking at different aspects of a glacier, for example, with different sensors that can give us different parameters of this particular natural phenomena that we're actually looking at. So that's actually quite interesting, and we need to have long-term data series to actually understand how the climate is changing over decades, for example, and to also understand what the trend of these changes are going to be. And satellite data are a great source for all this.
Here we are at the FEE Experience. It's the place in the European Space Agency Center in Rome, the Center for Earth Observation, where we display the work we do with satellites. And here you see the Arctic sea ice extent. And the Arctic extent, as you can see here, is monitored via satellites day and night, via radar instruments and via altimeters. And this is over the 40 years of time that we have data, and normally we look at the lowest extent of the ice, which is in September. And in September, this is the time where you have a real reduction of the ice mass over the Arctic. And we do plan to have, by 2050, unfortunately, an ice-free Arctic during the summertime. We do look at sea level rise since over 30 years with national, European, American missions. And we look at the trend of the sea level rise. Sea level rise, which is due to, of course, temperature increase, but also ice melting all over the world. We see the variability of such sea level rise, which is not homogeneous, and we see that the trend is passing from an average yearly of 3.2 millimeters to 4.8 millimeters per year increase in the sea level rise. And in the next station, we will look at applications which are related to the use of the land. So we look at forest, and we will look also at the quality of the air and the things which are very important for our daily lives. We see here the situation of the vegetation of the tropical forest in Brazil in 2018 and the biomass situation. And we compare that with previous years through satellite data. We look with radar, we look with optical data, and we look at deforestation, which is of course very relevant when you look, for example, at CO2 impact, and also fires. And over various years, you can compare the evolution over a specific region of such forest, and the evolution of such forest can also be monitored through future satellites that we're preparing, like the biomass one. Here we look at Sentinel-5P data, greenhouse gases data. Nitrogen dioxide over Europe, but this is a satellite that passes every day over all of the world, and we see the variability between week and weekends. So the difference is very relevant. It's due to traffic reduction and reduction in industrial activities. So satellites help us in climate change to monitor greenhouse gases, to monitor CO2, methane, nitrogen dioxide, and help us supporting the climate crisis.
We are sort of thinking about the whole food chain, from producing the data and building the satellite and developing new technology and addressing new science questions, to actually putting these satellites in space and then using these data, and when they've flown long enough, we are able to actually construct long-term series of climate-relevant data. So we're using different sources, not only ESA, but mainly to create climate data records, we call. And these are relevant data sets that tell us something on how the climate is actually changing over decades and even longer. And you know, with the onset of satellite data 40 plus years ago, we now really have quite some long data sets that go sometimes beyond 30, 40 years really from space, which is a very exciting source of data.
Now, with your experience in climate, do you think that this is something that we can stop, or even better reverse, or is it something that you just hope?
I think if we are managing to limit the global warming to a particular degree, then we will probably be able to at least hold the status quo that we have at the moment. But you know, this is a very difficult question. It's the sort of $1 million question, so to say. So I can't really answer that with a yes or a straight no or something like this. You know, I hope we will, and we have seen that with many countries that they are really starting to address it. So, you know, actually, I think we don't really have a choice. We have to limit our emissions. If we don't do that, then the destroying of our natural environment will continue.
I think it's quite iconically known that glaciers are melting, and it's all associated with climate change. We know this. I mean, we see it. If we go into the Alps ourselves, we can see the signs, the markings where the glacier was over the past decade. Satellites actually show us this globally. So it is actually a very recent development now with this program as well, that we have been able to monitor our glaciers globally from space over a long period. And what we see is that there is a global nature of retreat of these glaciers, and this is unprecedented. And in fact, it's very worrying.
If we now really manage to put effort in abating emissions, we'll be able to save, say, at least 40% of the ice. So half of this place is gone anyway, but still there will be something that we can look at and that we can show to our children, and that our children can show to our grandchildren.
I think nature is sending here a very strong signal to us.
I feel a little bit of urgency, and because it's me, I also feel hope that people will listen and understand the urgency of what is happening and how fast we have to react before everything that we have will disappear. So there is a lot at stake, and that is why this is now the time to act. Come on, buddy. I don't want to be rude, but you gotta get going. Okay.
you.